Good morning to all. In today's session, we're all going to learn how to process the data and use the statistical analysis. So let's begin with the definition about data editing. So what exactly the data editing called for? It is one of the most significant step in the research process, which involves that how a researcher could check and correct the errors, omissions, any inconsistencies in the collected data by him or her. It is also important to make ensure that the quality of the data, the validity of the research tools, the outcomes or the findings, and the credibility of research could reach to an ultimate results or not. Inaccurate data can lead to be based and unreliable results, which ultimately influence the overall research process, and it is also equivalent to edit the data before analyzing the same on the research study. Now we can come up to the next section, that is the techniques for editing data. So the first one is a visual inspection. So the visual inspection is one of the primary technique of editing data, which mainly used by the researchers when they are trying to examine the data to identify or correct any errors or any inconsistencies or omissions which to be occurred in the collected data. Next one is the computer verification. Computer verification refers, you can see, using the softwares or the any of sort of computer programs to check the data for any errors or inconsistencies occurred or not. Computer verification is one of the faster equipment which gives a more accuracy in the collected data or while editing the data, and it requires a pure programming skills as well. Next one is double data entry. So double data entry includes the entering the data into an Excel sheet twice by two different individuals to make them ensure that the accuracy and the consistency in it. There are two set of data, then they compare to identify or any sort of errors involved in it. Next section is importance of editing data. So the first is the ensure data accuracy. Editing data is always ensures that the data should be accurate while collecting it by the researcher. By correcting the errors or any sort of inconsistency, the researchers make ensure that the data accurately reflects the research variables and the parameters that they are used in the research study. Enhances data quality. Editing of data is also enhances the quality of the collected data by ensuring that the data is complete and consistent. So it always ensure to the researcher that the quality of the collected data is complete and consistent. And high quality data it always leads to a more reliable and a valid research findings or results. Next one is increases the credibility of research. Editing of data is essential to increase the credibility of research to make ensure that the research findings of the study would be accurate and consistent, and of course reliable too. The credibility is also equivalent in research to gain the trust of the audience and all of the stakeholders who are associated with the organizations or different organizations or industries. Now we can come up to the next section, that is the types of data editing. So the first one is category is the editing by stage. And when we talk about editing by stage, there are 3 or 4 types under this category. So the first one is the field editing, who basically collect you can see collect the data. So it will be collected by the investigator or the data collector at a point of data collection. and it will be collected immediately after the interview or any data collection process. The main purpose of field editing is to reveal the immediate issues like ineligible writing, abbreviated entries, or missed information to ensure the data is complete and leakable and consistent too. The next type is central editing. Who will collect or who will edit the collected data at a central location? So it will be performed or it will be evaluated by a single editor or a team of editors at one central place or location. So after collecting the data or the process of data collection is finished, automatically the form has to be returned to the office. So to correct any errors or entries in the wrong place, inconsistent units of the measurement, any logical inconsistency, or to fill up any gaps, it could be done after reviewing the other information in the questionnaires form. So it is very important that central editing is to be done by editors only or an associated team, and to make the identify the errors, inconsistency, any logical inconsistency, any inconsistent measurement of units, or any gaps involved in it. It could be done after reviewing any other informations in the questionnaires. Next one is, or the next category is editing by method or focus. So we have 4 or 5 types under this main category or second category. So the first one is validity edit. It mainly focuses on checking whether the data has been occurred within the acceptable boundaries for a specific field or not. Next one is completeness edits. It also verifies that there is no missing value or empty field in the data set. Next one is consistency edit. The researcher compare the different answers within the same record to ensure that there is a consistency or the logical sense involved in it. Next is duplicate edit. It also examines the entire records to identify and remove the duplicacy in the entries in the particular data set. Next one is outlier detection. So the main purpose of the researcher is also to identify all the data points that significantly changes from the rest of the data, and of course it requires any further investigation or correction. Next one is logical inconsistency. It also detects the contradicting, you can see entries within the record, and it would not be caught by a simple range or consistency check, such as person stated age is not matching with the date of birth. So it is all the when we talk about the data editing is also I detect the contradiction within the record in the data set, which could not be easily caught by a simple range or consistency checking as well. So it is very important to consider as a central editing, so that by focusing, it could be done through a verification of the past records, or you can see consistency checking would be a better option to detect the contradiction within the records. The next concept is data coding. So data coding is a process that how it transforms the raw data into the most structured format or manageable format, which helps the researcher to identify the patterns, themes, or relationship within their data set. It also assigns the labels or any of the numerical values to different pieces of information which based on the predefined criteria or any sort of categories. These codes could be a bridge between the raw data and the analytical phase of the research, which facilitates or which beneficial to the organization and accordingly interpreted the data in a research study. Why data coding is important? So there are few reasons to make sure that the data coding is actually important in a research study. The first one is data reduction. When researchers collect a vast amount of data, coding is actually helps to condense and summarize in a structured manner. And this reduction make it feasible to analyze a large data set more effectively. Next one is the data organization. Coding provides a systematic manner to categorize or grouping a similar pieces of information together, so it could be easier for the researcher to manage and analyze the data in his or her research study. Next one is pattern recognition. So the coding is always allow the researcher to identify the patterns, the trends, the relationships within the data which may not be immediately caught or apparent when any researcher working with the raw data. So through data coding, the researcher can easily identify the relationships, the trends, the patterns which cannot be identified with the raw data. Next one is the interpretation and analysis. So coding data is always helps or which termed as a route for the statistical analysis or the hypothesis testing. So through the coded data, researcher can easily run the statistical test on the coded data so that they can come out some meaningful conclusions. Next is comparative analysis. By coding data consistently, researcher can easily compare or contrast the information or data you can across different cases or categories or groups, so that they can identify a depth insight about the theories, about the foundations that involved in terms to patterns, relationships, or any sort of, you can say, groups. Next one is the examples of data coding in research. There are a few examples which gives you an overview that data coding is actually used in the qualitative research as well quantitative research, survey research too. So when we talk about the qualitative research, so in qualitative research, data coding is used to categorize and analyze the textual and the narrative data. For example, let's imagine a study on the customer feedback about a new product. So the researcher can code the customer comments into the major categories like product quality, customer services, pricing, and delivery. So in the qualitative, it begins with the naming of the categories, and the customers could easily comment on these categories, and immediately assign and the comment would be assigned one of more all those codes on the main topic, whether related or not. So in this way, data coding plays a significant role in qualitative research, which categorize the, you can say, the narrative and the textual data. Next one is survey research. In survey research, coding can also include assigning numerical values to the responses. In this category, we use the Likert scale or the rating scales, where we just give our responses to numerical values. Like if we order to assess the job satisfaction level, the responses immediately say into a statements like strongly agree might be coded as 5, or agree it might be coded as 4, neutral could be as 3, disagree could be as 2, strongly disagree could be as 1. So this is how the numerical coding is to be done in a particular, you can say, portion or the options of the questions, which is done through a linked scale or the rating scale, and these codes are always enables a quantitative analysis of the survey data. Next one is the classification of data. So the classification of data is ultimately a systematic organization of a raw data which turn into a groups or categories and based on the shared characteristics or attributes. And this process is always transforms the unstructured data into a structured format, which make them easier to analyze and draw the meaningful conclusions. So the main purpose of the classification is to, you can say, systematic organizing the raw data into a groups and categories, which is based on the characteristics of the population or different attributes of the population. And this whole process always reflects a meaningful conclusions to the stakeholders, to the customers, or to the other researchers who are doing a similar topic. So in this particular section, the data can be classified on the basis of location, time, descriptive characteristics, and of course the measurable characteristics as well. So this is a basis of classification. The first one is a geographical classification. In this particular basis, we can come up that the categories to be based on the location or the region. When we talk about the chronological classification, it is totally based on the different periods of time. When we talk about the qualitative classification, it's all about descriptive in nature, which categorized into two main parts. It's simple classification and manifold classification. The next one is the quantitative classification, which is based on the characteristics that can be measured. So let's have a small overview of all of these bases with the respective examples. Let's talk about the geographical classification. As I already stated in the diagram, that the classification of data can also be based on the geographical location or the region, and that is called the geographical or the spatial classification. So, for example, presenting the population of different states of a country is based on the geographical location in India, like Assam, Bihar, Goa, Gujarat, and Haryana. So, in this tabulation, the classification of data is based on the the region is based on the location in India. So the population has already been shown in the tabular statement, that is in thousands. So if you can look up the values. So this is how the geographical classification has been done in the tabular way. Next one is the chronological classification. That this type of classification is to be based on the different time periods. It could be years, it could be months, it could be you can say quarterly basis, and that's why when any of the classification of data is done based on the different time periods, that's called the chronological and temporal classification. Let's take an example to understand this concept. The number of students in a school in different years has been presented in a tabular statement, which is based on the time period, say year. So years has already been given: 2002, 7, 2012, 2017, and 22. So the number of students has also been shown in the numerical values, which has been consistently increasing in every years or different years. And when any class, and this type of data has been classified based on the different time period, that becomes a chronological classification. Now we can come up to the qualitative classification. So this type of classification is totally based on the descriptive and the qualitative characteristics like region, caste, sex, gender, education, where we talk about the socio-demographic classification that also comes under the qualitative, because here we are talking about the descriptive variables in nature. So that when any of the classification of data is done, is done or is to be based on the descriptive in nature, that's become a qualitative classification. So qualitative classification, it cannot be quantified, but it is based on the two main types: a simple classification and manifold classification. When we talk about simple classification, it considers only one attribute. That means the data is classified into two main classes. That's called simple classification. Let's take, we talk about the one of the main case, that is population, and it's classified into two classes or two main parts, that is literacy or illiteracy. So, or even we can talk about the two main parts, population, males and females. So that's called a simple classification, where it takes on one attribute, that is population, and it classified into two parts, that are literate or illiterate, males, females, etc. So this is how we can call the this category or this classification, that's called simple classification. And the next category is the manifold classification. When the researcher is considering more than one attribute, it becomes manifold classification. That means the data can be classified into different classes or in subdivided into more subclasses, and that becomes a manifold classification. Let's take an example. As in the simple classification, I stated that population is classified into two main classes or parts, that's called a literate and illiterate. Now, if we do a more classification or turn into a more subclasses, then literate we can talk about male and female, and illiterate we can also talk about male and female. Then again we can say we are showing a more subclasses of the main class, that is male, married or unmarried. Same for the case female. Same in the case of illiterate, male, married and unmarried, and female, married or unmarried. So this is how, when a researcher is classifying the data into a different classes, then again is subdivided into some more classes, it becomes the manifold classification. The next classification is the quantitative classification. So this type of classification is based on the characteristics like age, height, weight, income, etc., which is measured in quantity. That's become the quantitative classification. Then, like any variable which is measured in quantities, which is measured in mean number, in the numerical values or in numbers, that becomes a quantitative classification. And that one of the case which has been considered the weight of students in the class is also been classified in as a quantitative classification. The weight is already mentioned 20 to 25 till 45, and the number of students is also mentioned in the tabular statement, that is 5, 18, 6, 10, and 9. So this is how the quantitative classification has been done on the basis of the characteristics of the, you can say, individual. Now we can come up with the next concept that is called the statistical series. So statistical series is all about a collection of data arranged in a specific order to show the statistical components in a data set, like to show the frequency, variation, distribution of the particular phenomenon or any event. So these series are mainly used in the various research study so that the data can be organized in a structured manner, and it which makes the researcher more easier to interpret it and analyze the data. Let's take an example. Let's say you want to study the consumption pattern of the specific product in a particular region. So you just start the collecting the data related to the product sales, customers feedback, market trends, or any other, you can say the taste and preferences of the customers. You can see the patterns which are the future patterns of the market in that same region. So you just arrange everything in a chronological or the geographical order so that you can easily form a statistical series, because you have to come up with the pattern in the numerical values, using the variations, using the frequencies, using the percentages, just to reflect your you can say results while analyzing the data. So this series which always helps to understand the pattern of the consumption, the peak season, the customer preferences or taste, and so that it can be reflect through the series of the statistical tools, like could be the frequencies, central tendencies. We can talk about the measures of dispersion. We can talk about the correlations or any other parametric and non-parametric distributions where the data is already being available, and researcher could easily interpret it and analyze it. But before that, the data should be, you can say, should be in a structured or organized manner. So this is how I already told that statistical series is classified into two main bases: on the basis of characteristics, on the basis of construction. When we talk about on the basis of characteristics, we have three: that the time series, spatial series, and condition series. Is time series is the classification to be done on the time basis. You can see spatial series done to be on the basis of location, condition series on the basis of conditions. But when we talk about the second basis, on the basis of construction, we have three series: individual series, discrete series, and the continuous series. When we talk about individual series, we look on the individual observation. But when we talk about discrete series, we always talk about the individual observations with their respective frequencies. Here we can talk about the grouped and ungrouped frequencies, you can see distribution. But in case of discrete, we always talk about the ungrouped frequency distribution. But when we talk about the continuous series, we consider the grouped frequency distribution, because in this category we always includes the intervals, class interval. So let's begin with the time series. So if the different values taken by a variable in a period or according to the period, if any value shown according to the time period, could be years, it could be months, then automatically and arranged in a chronological order, such type of series are called time series. So time series is a statistical series by which a given data is presented according to the time unit. It could be day, it could be month, it could be week, it could be year also. So you can see an example, the population of Delhi NCR during the years 2010 to 12 and the years, respective years has been given and the population or the numeric digits of the population is also being shown in the tabulation way. So this is how that any of the values, if it is shown or arranged in a chronological order or according to the different time period, it becomes the time series. Next one is spiritual series. If the data is arranged according to the location or the geographical classification, it becomes a spiritual series. And here the time factor remains constant. There is no role in the time factor, and the place would automatically get changed. It could be any state. So example of the spiritual series, the following details is the sex ratio of the 6 different states of India as per the census of 2011. So if you look up the sex ratios of different states, it's from Uttar Pradesh, Maharashtra to Tamil Nadu, and the sex ratio is already given. It's 912, 929, and so on till you can see Tamil Nadu is 996. So when we talk about the data, it's consistently increasing as in the respective states shown in the tabulation state or tabular state. The next one is the condition series. If the data of the series is classified according to the changes occurring under certain conditions or the condition has been be put on. So it is called a condition series. We can take up an example, the following table showing the arrangement of 40 students in the class according to their age. So the age is already given 20 to 25 and the number of students is already given 5, 8, 10, 4, 6, 7. That means 40 students has been arranged and according to the age, the number of students has been classified based on one condition that there should be a 40 students in the class and according to the age, the 40 students has been classified according to their ages and that's become a condition series. Next one is individual series. So the series in which the item are listed, it's called individual series where the separate values is going to be measured on each item. So let's take an example to understand this concept. The marks obtained by 10 students are arranged in the serial number. It's shown in the table below. So the numbers is already given 1 to 10 and the number of students is given 60, 55 and so on till to 10th serial number is 88. So of course the number of students is also been increasing consistently. It reaches to the highest digit that is 88. Next one is discrete series. So if the number of observation is of a study is large and arranging data in individual series not a solution, then we come up to a discrete series rather move or to an individual series. Because when we talk about the data is large, then discrete series is always a better way to present the data in organized manner. So it is a series in which the individual values differ from each other by a definite amount. So in this type of series, different values of the variables are shown with their respective frequencies. So if any of the individuals' values shown with their respective frequencies, it becomes discrete series. If you look up at the tabular statement, the marks is already given 10 to 22. Telemarks is also given that the 10 marks you can say comes comes at 6 times, so the frequency becomes 6. 15 marks comes fourth times, the frequency becomes 4. 18 marks comes 2 times, frequency becomes 2, and so on. So the total students is 22. So if any different values of the variables with their respective frequencies has been shown, that's become discrete series. Now we can come up to the continuous series. So in this series, the measurements are only approximate, and the approximate are expressed in the form of the class intervals, which has no and. So the classes are formed from beginning to end without any breaks. That means it's continuously the values begin and accordingly without any breaks, and that's become a continuous series. There are various names to call continuous series like frequency distribution, grouped frequency distribution, series with class intervals, series of grouped data. That's become the continuous series. If you look at the example, the marks in the form of class intervals has been given, or the classes has been given 0 to 10 and so on till 60 to 70, and along with their respective frequencies, that is 6, 4, 5, 2, 4, 4, 4, and the total number of students becomes 30. In this, that means the 6 students has come under the marks 0 to 10. 4 students have come under the marks 10 to 20. 5 students have come under the marks 20 to 30. 2 students comes under the marks 30 to 40. That means there are 2 students who scored the marks under 20, under 30 to 40. Say there are 4 students who marks comes under the 60 to 70. So this is how the grouped frequency distribution has been shown, where the differences of the classes remains the same, that is 10. So the difference of the class is 10, and it should remains the same in the class intervals, and that is one of the variable called marks. Let's we talk about the next section, that is table. So what is exactly the table called for? So table is a structured arrangement of data or information in rows and columns, which is mainly organized for the clarity, for the comparison purposes. So key characteristics include its two-dimensional format with the horizontal rows and the vertical columns. So when we talk about the horizontal rows, it represents the individual records, and vertical columns represent the specific fields and attributes. So tables are more essential to simplify the complex data. It facilitates the comparison and enables the efficient data entry and used for the data analysis and keep all the databases and research in a one way. Characteristics of the table. The first one is rows and columns. So tables is fundamentally a grid-like structure which have a horizontal rows and vertical columns. Structure arrangement data within the table is systematic, organized, and make it easy to read and understand. Data interpretation. Each row typically contains specific data for a single entity and occurrence, like a particular customer, while each column describes a specific characteristic or attribute of that entity. So this is how the data into one table is to be represented in a more structured way. Data types. The columns can contain various types of data like tasks, numbers, dates, and hyperlinks. So the headers is also there. Tables, of course, gives a descriptive heading for each column and which represent the type of information. Purpose. So the tables serve to simplify the complex information in present data in a compact and accessible manner. Versatility. The tables are used in many contexts where the from furniture in a room to data structure in computer databases and format information in publication. If you look up the publication, the data is represented in the form of a tables. So that's called versatiles. Database context. In databases, the table stores information about a specific subject and uses the primary and foreign keys to establish the relationship between the different tables. Next one, we talk about the graphical presentation of data. So the graphical presentation of data uses the visual elements like charts, diagrams to represent the numerical information which is easier to understand, analyze, and interpret the complex data set. So it could various types of graphical formats like graphs, line graphs, pie charts, histogram, and it depends according to the data type and purposes like comparing the values, showing trends over time, instructing the parts of the variables of a whole variables or part of the variables. Let's talk about the pie chart. So it is a circular graph that is divided into slices and each slices represent a numerical proportion which is proportional to the quantity of the item it represents. So a pie chart is a graphical representation of a statistical data in the form of circular graph. So if you look up the diagram where the percentage of textbook users in different states has been shown, that this is a percentage of population who are using the textbook users using the textbook in different states like UP, Bihar, Maharashtra, Madhya Pradesh, and others. Next one is the two-dimensional diagrams. So the two-dimensional, that is 2D diagrams, is a flat graphic representation that uses only two-dimensional, that is length and width, to display the data using various shapes like rectangles, circles, or squares. So when we talk about circle, the pie chart is one of the main example and type of the two-dimensional diagram because that pie chart is drawn in a circle. Yes, we can talk about the one of the diagram which has been shown in the form of you can see squares. So which has been shown over here. That is frequency, number of students, and if you look up, that's also called a two-dimensional diagrams. Pictograms. Pictogram is also called the pictogrammes, which is commonly used to reflect the statistical data. It is created using photographs. So the diagrams points to the nature about how the photos to be taken and which is going to be represented in the study. So it could be used in the medical studies where the treatment is to be given to the patients and the photographs has been clicked and show into a statistical analysis, and that's become the histograms. So histograms are the visual, appealing, and simple to understand that what you are trying to show in the in real, and that could be shown in the photographs as well, or through the use of the pictograms. So it making them ideal for presenting the statistics in the journal public. If you look up if you read the Economic Times or the diagrams which has been, or the pictures which has been used, which represent some, you can say, which represent in the form of the pictures, which gives them a message to the reader to understand. That's called pictograms. So a properly chosen image is used as a symbol to represent the units of or values of any variable. If you look up in a picture a situation of poverty, It's called pictogram. If any of the situation is showing in an image, like unemployment image has been shown in the form of a 2D diagrams, and it's shown an among in the different state. This is employment and unemployment rate in the percentage that also shown that also called pictograms. For example, if there is an increase in the number of airline companies is to be depicted over time, so airplane would be the ideal symbol. So through the airplane, you can show the figures in the image, and that's become about on the declining part of the airline companies or increasing part of the airline companies that will be shown in a percentage in a particular image that's called a pictogram. It could be the image could be in circle, the image could be in rectangle, the image could be in square. So this is a way that how the pictogram used. If you give any social message, you can use the images for that. So you can is oxidize, the flammable is self-reactive images has been shown, explosive images has been shown, acrotoxic images has been shown, burn skin damages eyes has been shown in this. Even the gases under pressure, which has been shown, the respiratory centralizer, reproductive toxicity has also been shown in a very small image, which shows a message to you, which shows precautions to be taken by you before you can say do something which is harmful for the health and of course for the society. So toxins to aqueous equipments, environment, X-rated toxins harmful irritant to skin. So this is how the GSS pictograms images or health related images has been shown. The next one is line graph. Line graph, in other words, we can call a line chart, line plot, is a graph that utilizes the points and the lines to represent changes over time. So it keeps changing the pattern of the rainfall. It changes over a period of, you can see, years. So it is a chart that shows a line joining several points, or a line shows a relationship between the points. It represents the quantitative data between the two changing variables with a line or curve that joins a series of successive data points. So have a look with the diagram. So it's an average monthly rainfall city 1 and city 2. If you look up the line graph or line chart, then according to the number of months, the average monthly rainfall keep on declining, and suddenly it keeps increases just after the July month. But when we talk about the city 2, it begins with increasing, then declines, and again it would increase, and consistently it would decline. And after July, it's steady increases the monthly rainfall after July till December. So this is how the line graph has been drawn and shown in the form of a graph paper. So next concept is t-test. So what are the t-tests actually? So that these are called the two sample t-tests are the statistical test, which is used for the comparison that how the researcher compare the means of two populations, and that's become the student t-test. So it is the output, the statistic output. It's generated from the t-test, which helps to know that whether there is significant differences between the mean of two samples or not. So what is the actually main purpose of the t-test is just to identify whether there is a significant differences between the mean of two samples or not, which is going to be you can see, which is going to include in the study. And if it is not, it could be due to the sampling error or the random chance of any kind. T-test is classified into two parts, that is paired t-test and the unpaired t-test. So, and this application, the two sample t-test is mainly used in biology, business, and psychology specializations. Before I come to the main part, it is very necessary to understand three major concepts. The first one is the p-value. It is called a probability value that while observing the data, what could be the probability of your data? Whether the assumption is to be considered a null hypothesis, that there is no relationship, there is no differences between the means of two variables or two samples, or it is true or not. So this is how, and this value will actually reflect whether there is a relation or no relation, whether there is a significant difference or no difference. So how you conclude the result based on the p-value. So a low p-value provides a strong evidence against the null hypothesis. If there is no effect or no relationship, that means a low p-value means that there could be a relationship between the two variables, because there is a strong low p-value gives a strong evidence against your null hypothesis, which suggested that it is a statistically significant relationship between the two samples or two variables. So before you conclude any result based on the p-value, it is very important to prepare the null hypothesis, that there is no relationship, or there is a relationship, or the relationship is not true. This is how you can conclude, and based on the value of p, you can, or probability value, you can easily conclude the result. So if it is low, that means low p-value, it is statistically significant and it shows a strong evidence against your null hypothesis. So researchers can easily compare the p-value to the significance value level, that is alpha value. So alpha value is already given in the question, in the practical problem. It could be 0.05, or you can say 0.01. If it is a low, then of course the decision could be made up against the null hypothesis. Next is significance values called an alpha value. Alpha value could be a 0.05 or 0.01 as well. And it is mainly considered these values in order to decide that your results are statistically significant or not. What does it mean? So if you accept the 5% chance of incorrect, it means you are rejecting the null hypothesis, even you know that null hypothesis is true. So if the null hypothesis is actually true, and knowing this fact, you are rejecting the null hypothesis, is called type 1 error. If you know if something is right, knowing this fact, it is right, and you are rejecting it, it becomes type 1 error. How it is being used: if your p-value is less than the alpha value, it could be 0.01, it could be 0.05. That means a researcher has to reject the null hypothesis and the results will be statistically significant. And the last is degree of freedom. So degree of freedom is a number of values in the final calculation of the statistics. So it is n minus p. N is a sample size, you can say p is a number of parameters. So degree of freedom is used in the various statistical tools. It could be the t-test, z-test, chi-square test, so that in order to estimate the uh, uh, statistical results, or you can say meaningful conclusions or statistical conclusions. That's it for today. Thank you so much for listening this lecture. I will come up to a more and more interesting and relevant topics in the upcoming session. So till time, thank you and namaste to all.